Now, Advanced Mate basically reduces the need of complex geometry or multiple standard mates by offering direct intelligent constraints that simplify the assembly setup and improve the accuracy. Now, it also provides specialized motion control that goes beyond a simple alignment. So, allowing gears, cams, screw, sliders, hinges, and centered profile to behave like a real mechanical system. So, such achievement in assembly is not possible by standard mates. That's why these SolidWorks provide the advanced mate. They also simply simulate the real-world mechanical relationships such as rotational ratio, constant travel limit, cam follower, contact, or motion along the predefined path. So here we have profile center, symmetric width advanced mate, path mate, linear coupler. And also we have a distance mate and the angle mate. Now let's explore the first part, which is profile center. So profile center mate automatically centered a parts profile, circular or prismatic, inside the another profile. So here we have a rectangle face and this component. So we are going to center the second component exactly over here. So with the one single mate, we are able to fix the position of this component. So perfect for placing bolts in slots, centering blocks inside the frames, locating cylinder parts inside the openings, and remove the need of for multiple mates. So let's explore this in SolidWorks. Now open the new assembly. Now let's add the component. So I will go with the default setting. So because of this second, that is automatic browse when creating new assembly. And because of that, we have this window open to browse the new parts. Now let's add the first one and second. Now because I have chosen these two parts at a time, the first was this and second was this. So first will remain fixed, second will be in floating condition. So click open. Now let's try to add the profile center mate. So go ahead and click on mate, and inside that click on advanced and choose this profile center. So for mate selection, we have to select this face and this face. So it automatically positions the component. Just look at it. It simply mate the center of each profile. So with this, you can simply place one component or position one component based on the profile center. Now let's cancel this again, expand the mates and edit this profile center mate. Now here we have one option called distance. Let's try to add some distance. Let's say 10 mm. So what exactly is that? So these mating surfaces are offsetted by the provided distance. Now let's flip these dimensions so that part will come out. So here you can see, though they are centered, but between them there is a 10 mm distance. Sometimes when you require distance between two profiles, then you have to use this distance options. Now let's make it 0. Here we have orientation. Let's try like this. So you can understand what does it mean. So you can change the orientation of profile of a second part. Let's try one more. So start the assembly document. Now this time I will add these two components. And click OK. Start the mate. Inside that advanced mate and select the profile. Select this one and this one. Right click. Now because we have already applied this one mate in assembly, the property manager remain opens here. So under this box, it lists out the number of mates we have used. Here we have only one profile center mate. If you want to edit it, just simply select it. It will take you to the values. So from here, you can adjust the required things. Let's flip the part. Okay. If you want to lock the rotation, because this is circular part, you can lock the rotation as well and click OK. So it is very useful to align or position the components in assembly based on the center of a profile. Now in Symmetric Mate, it's simply center component between two planes or faces. Very useful for symmetric design positioning. We can position these two components symmetric about selected plane. And for that, we need to use this Symmetric Mate. Start the new assembly document. So add two component. But before you add, please make sure you select that component first, which you want to make it fixed. Click open. And click open again. Now we have two components, so I will press Ctrl and drag this part to create a copy. Now let's add some basic mates, standard mates, to place this component in the slot. So this part, control this, and coincident. Similarly, this face and this face coincident. Now you can see it simply reciprocate in the given slot. Now let's add the standard mates for second component. So select this surface and control this surface and position it. Similarly, select this and select this top surface and coincident. Now we have two components. Now at this moment, they are not connected. They are independent. Their motions are independent. Now let's try to add the Symmetric Mate. For that, we require some reference plane. So inside the assembly, you can add the plane. So for that, this is our first face and this is our second face. So between them, a mid plane is created. Now I will use that plane as a symmetric plane. So click Mates, go to Advanced, click on Symmetric Mate. Now I have to add the plane first. So I will go over here and select this. Then I will choose the faces of a two component, which we want to make it symmetric about. Now here, let's click OK. Now moment I move one part, second part also repositions. Means it will maintain the symmetric about the selected center plane. So they are very useful in certain cases. So Symmetric Mate simply make the movement of a component, two component, symmetric about a plane, selected plane. In Width Mate, the Width Mate is used for making two planar faces or a cylindrical face or an axis of a component centrally aligned between two planar faces. So here, this is the conditions of another component. So we have one bucket and one arm. Now I want to position this arm, this surface and this surface between these two references. So for that, we need to use Width Mate. So we need to select four faces. One is called width selection 1, that is this one and this one. Now they are color coded, so it is easy to visualize in graphic window. Then you have to choose the second component surfaces. So that will position the component between the selected surface. Now along with that, we have one more constraint option over here, centered and others. So what it says, when I select the centered, this surface and this surface will remain in centered from the selected surfaces. If we go in detail, for the other options, we do have a free, dimension and percentage. Now free means what? It will, when I drag this, it will move within this range. the second component will move within this range. The other dimension and percentage, when you apply say 5 mm, so from the selected, the 5 mm distance will be left and the component positions. It's the same thing for the percentage. Open new assembly document. Now let's insert the component. So I will insert the bucket and then the arm. Just ignore these messages. Now I want to reposition this first component, so I have to make it float like this. Okay. Once it is done, right click and fix this. Now right click the second component and rotate for the appropriate orientation and drag it. Now let's apply the width mate. Go to mate and in advance and select the width mate. Here the first selection will be our width selection, that is two opposite parallel surface of a first component. So this one and this one. So it find the distance between these two. Now the second width selection is this one and this one, and right click. Now it does position it, but the problem is still we have to add one more constraint, that is concentric constraint. Add that. So go to mates, in standard let's add the concentric. So select this surface and this surface and right click. So here if you closely observe, when I move, the second component remain in center. Okay. So let's go ahead and try to add this. Now because this is centered, now let's say free. So when I choose the free, it simply, let's click OK, and it simply move between the two selected width options, that is this surface and this surface. Okay. So free option allow the movement of a second component. Again, let's edit it. Now instead of free, let's put the dimension. Okay. Maybe some distance, let's add the 1 mm distance. Okay. So here, this 1 mm distance is left. Now let's flip it. Now let's increase 1.5. So you can see very easily. So this is 1.5 mm distance. If I flip this, the other surface will be at a distance of 1.5 mm. Same case, but here we, in case of percentage, we have to apply it. Let's say 40%. So this is 40%. Okay. Let's flip the dimension again. So this way you can apply the constraint. So it is very helpful to position the component between the two parallel surfaces. Now in path mate, it forces a component to follow a 2D or 3D sketch path. Basically, it is useful in cams, sliders, chain, links and robotic movement. Here we have one pin and we have a plate. So inside that we have created the 2D sketch, which is basically a path. So our target is to place this pin exactly over here, and we'll try to drag so it can move along the path. Now for that we need to select the vertex, which is basic requirement. Then we have to select the path. After that, what we have to give the path constraint, pitch and yaw control and roll control. Now what exactly is this? Let's say I have a part like this and I have a cube like this. Okay. So because here the part is connected with to the path to a point, by a point. So this may roll like this or it may move forward backward. Try to understand like a CP is moving on a C. It may having a pitch and yaw movement, right? It can roll back and forth left side, or it can have a front and back motions. So to control this, we have to provide this pitch yaw and roll control. Start new assembly. Now here, insert the plate. Okay. Now let's add that pin. Now let's try to connect this pin to this path using path mate. So open the mate and in advance select the path mate. Now here I need to select the vertex. So for that I have to expand the design tree, and the second component is pin itself. So here I have a point. If it is not available, then you have to add in part modeling. Now in part selection, I have to select this path. So let's go for selection manager and close loop. I will choose this close loop options and right click. So moment I select it, that point simply attached to this path. Now along with this, let's say I stop here and click OK. Now let's drag this. Now see how the pin is moving. It is simply does follow the path, but it simply move back and forth and having a irregular movement. So what we can do here? So let's cancel this. Again, expand these mates and delete it. So let's drag the pin over here. Now again start the mate, go to advanced and choose a path mate. Here let's expand design manager tree and select this. Under the selection manager, let's choose the closed loop. So right click. Now instead leaving all this constraint to free, let's apply the first part. First thing is pitch and yaw, because in path constraint we want free movement. If I choose distance, then the number of value which I provided here, let's say 10 mm, let's say 10 mm. So it pushes the pin to 10 mm from the selected reference point. So let's go to free options over here. Now again, let's try the pitch and yaw control. So let's say follow the path. What it says, it simply goes along the path. It does not move forward or backward or deviate from the movement of a path. So here the axis of this part is indicated by these three colored arrows. So you can choose which way you want to control. It should follow the X direction, so it remain in this way. Now let's say apart from that, if I click on flip, it will simply flip the position of a pin. I'll go with these upper positions, vertical positions. Now let's control the roll. Roll means moving like this while moving on the path. So we want to control the rolling motions. So instead of free, let's apply vector. So when I choose vector, let's say this edge, so it keep the pin vertical. It does not allow rolling back and forth. So let's click OK. Now let's drag this. Now see, earlier pin was moving erratically. Now it is systematically follow the path, right? So this way you can apply the path mate. You can see when you drag it, it simply follow the path. Now the linear coupler advanced mate simply couple two linear movements with a ratio. Now what it means, let's say this purple slide moves by 1 mm. Then you define the ratio how much the green slide will move, let's say 2 mm. So it is double the ratio. So if this is moved by 10 mm, this will move by 20 mm. So this mate is used for translating the linear motion of component concerning to each others. So they are coupled. That is what the meaning of this mate. So you have options over here. You can control the ratio. If you click on reverse, the part will move in opposite directions. If it is untake, it will move in same direction. But their movement will be controlled by this ratio. New document. Now let's add the component. The first component is this, second is this, and third is green slide, and click open. So one by one, I will add the component. Second component, then the third component. So here the first component is fixed. Now let's apply the standard mates. So for that, select this surface, rotate, control this surface and make it coincident. Similarly, select this surface and control press this surface, make them coincident. So with this, you can see it is simply sliding in particular guide rail. Now same way, let's apply coincident relation between these two surfaces. Select this and select this surface and make them coincident. Now you can see it is also sliding on a purple guide. Okay. Now let's apply the linear coupler. Go to advanced and choose linear. Here we have to select the two faces because we have a prismatic shape. So I will choose first part this one, second part this one. Or you can select the reference point on a particular part. Now see two arrows having color coding. One is purple, second is pink. So this indicate they are in the same direction. The movement will be in the same direction of these two parts. Now let's apply the ratio. So here I will say make it 2. That means when this purple guide will move 1 mm, this green will move by 2 mm. Let's click it. See. It is easy to understand the meaning of coupler, linear coupler mate. Now let's edit it again. This time I will choose the reverse directions. So arrows get reverse and let's say click OK. Now move it. So two components having ratio of 1:2 but the moving in opposite direction. So linear coupler mate will simply couple the linear motion of two components. If one moves, second moves based on the given ratio. Now in limit mates, now here we have two limits in the form of linear distance and the angle. It simply allows components to move within the range of values of distance and angle. Here we have two components. Now I want to restrict the movement of this top part starting from here to certain location. So let's say this is 0, 0 and this is let's say 50. So this will help us to restrict the motion between two values. So it limit. So that's why it is called limit mate. Similarly for the angle value. So in angle limit mate, we simply restrict the movement of a part by giving the angle values. Start new assembly. Now this time I will browse for 9.13 and click the component, first component and the second component. Position them. Now let's apply the standard mates. So first is this one and control this one and coincident. Okay. Now because it is coincident, that surface are lined up with that particular this surface. But still we need to apply one more constraint. So here now it's move in a particular directions. That is it reciprocate. Now let's control the movement, let's say here, starting from here, it should move up to this location. So I want to apply limit distance mate. So for that, go to the mate, into advanced, and select this distance. Now before that, I have to select two surfaces, one this and second this. So minimum distance is 0, maximum distance is 50, minimum is 0. Okay. So right click and OK. So here what we have is 0 distance and 50, 0 and 50. Now let's add it and change the value. So instead of 0, let's add 10 mm and let's make it 40 and click OK. Now here what we have is, so it will leave the 10 mm distance, and from that motion will start and it will stop on 40 mm distance. So this way you can apply the limit mates in linearly. Now open new assembly file again. This time I will choose 9.30. Place these two parts. Now let's apply concentric mate. Select these two surfaces and apply the concentric mate. Top surface, control this surface and coincident. Now see, we have applied the standard mates. Now I am able to rotate this lever, but I want to control its motion from 0 to 90. So for that, to provide these two limits, I have to go to the mates, and under the advanced mate, I have to choose the limit for angle. So here before that, I have to choose the surfaces. So I will choose this edge and this edge. So minimum is 0 and maximum is, let's say, the 90 degree. Okay. And click OK. So this is 0 and maximum is 90. So lever will move from 0 to 90. This is what meaning of limiting the motions. So in angle, we provide the minimum value and maximum value.